Hi, good morning. It's Jim from the Mavstar Observatory. Guys, we've got a load to get through today. As you know, it's the 17th, and on the 17th we whip out the SD cards for the TriMag, the magnetosphere sensor, and we've also had some data in yesterday from Perth, Australia, from one of our superstars down there. Jeff, thanks very much, and we're glad you're still with us. So we've got so much to do in this video. I'm going to try and pick up the pace a little bit and hit the ground running. So as always, guys, big thanks to the few people yesterday and the day before that donated on PayPal towards what we're doing here at the observatory. If you don't know what we're doing at the observatory, we've pretty much got equipment now in the United States, Arizona, Kentucky, South California, Hong Kong, Perth, Australia, and on the Gold Coast of Australia, so we're covering both east and west coasts. This month we will have muon detectors in Brazil and south coast of Australia. So it's all happening, and it's down to a few people that are making donations now. Just tell you a little bit of a story very quickly. I'm usually one of these people that like to get things done quick, so I jump in the shower most of the times. But yesterday I just thought I'd have a relaxing bath, so I filled it up, got the bubble bath going. I'm sitting there in the bath for about, I don't know, an hour, having a good old soak, crinkling up. And I've got my phone set, if anyone makes a donation on PayPal, to send a notification. It's usually like a ding, and I'm sitting there in the bath, and a notification went off, and then a couple of minutes later another notification went off, and then another one, and in total we had about 4 notifications in that short space of time. And it's a good time, isn't it, when you're in the bath, to think about these things. I'm just thinking, what is the synchronicity of this? How come 4 people from different places around the world all of a sudden choose at this moment to, make a little contribution to our observatory? It was just really strange. Anyhow, guys, I'm sure that there is a supporting force other than what is in our normal reality, what I'm talking about. I think that we are being helped here at this observatory. I think that whatever this force is, it definitely is encouraging a few people to help us now and then with a bit of a contribution towards what we do. So anyhow, let's get on with it. Right, okay, so we're looking at the latest magnetic North Pole position. I'm going to pull up now, but before I do, I just want to zoom out so you get a bit of an idea as to where these pins are on our planet. So I'm just going to back it off so you can see. I know they're going to start getting closer and closer over the last month. Again, like the month before, just short of 4 miles of progression towards Siberia, and 4 more miles closer to that all-important 40 degrees. If you're wondering why the 40 degrees is of importance, it's because of experiments that we conducted on a compass and a magnet. Basically what we did is we encouraged the compass needle to move into the weaker field lines, and we can see that when it gets to around about 40 degrees of total movement, it starts to enter those weaker field lines, and it's at that point where the compass needle flips over, so it does a reversal. And this is exactly what we expect to take place on our planet. It's no different from a bar magnet, our Earth's magnetic poles, or dipoles if you want to call them that. They do have strong field lines. That's where the North Pole or the South Pole doesn't move at all. That's when we're not in a reversal. But when it starts to move closer and closer to the 40 degree mark, then we start to enter the weak field lines, and when we enter the weak field lines, it goes into a reversal. So as you can see, we are still migrating. We've migrated another 4 miles towards Siberia. The pole is still moving in that same direction, and as you can see from the diagram, we are looking at a total migration over about 100 years. But more recently, it's covering more distance in shorter spaces of time. If you go onto Pole Shift News and just have a look at the very first chart I've got on the TriMag, you'll see how these accelerations have been taking place. So as we get closer to that 40 degree mark, we're going to start seeing things happen a lot quicker on our planet. Let's have a look at the GPS coordinates, because I know some of you are also pinning your own Google map and tracking the migration. So let's have a look at the longitude and latitude for you. So here is your northerlies and easterlies, if you want to call them that, or your longitude and latitude. You can see it's 83 degrees north by 126 degrees east. So put that location on your Google map and pin it and put the date on it as well, and you'll be able to track the migration and the migration speed along with me, guys. So let's move on then to having a look at the Perth data, because that's interesting. So we're looking at the data that Jeff sent us over the weekend, and I think it speaks for itself. You can see yourself there has been some activity, let's just call it that. Look at the shifts that we've been noticing over the last month with regards to the high intensity region that is creeping up over Australia right now, but we're just focusing on Perth at the moment. But you can see there has been more than one shift in a large amount of microteslas. And you know, if we just compare what's been going on before this, you can see that the activity has suddenly picked up over there. And we've been covering Perth now for quite a few months. We had a bit of problem with one of the magnetometers. We got that sent out. We actually repaired the magnetometer. It was just one of the pins was soldered, but not completely making a full contact. And it was that was causing an intermittent problem, but very quickly and easily resolved. But look at the difference in the data this month compared to the other months. We can see that, you know, things are slowly, gradually picking up, and I believe it's because we're moving closer and closer to that 40-degree mark. Let's have a look at the TriMag data and just see what we've got there. So as you can see, we're looking at the latest TriMag data, and things have calmed down a little bit with regards to those magnetic jets, you know, the big spikes that we was getting. Let me just go back a few months as to, you know, the time where we were seeing a lot of activity. You can see that, you know, gradually over the last 4 or 5 months things have calmed down. But in these next charts that we're looking at, like this one here is a good classic example, from the 17th of the 6th 2019 to the 17th of the 7th 2019. You can see we had some sharp upticks in movement over the magnetic North Pole, and this was where it was moving like, you know, nearly 100 miles one way and then 100 miles back the other. And it seems to have calmed down from the months on from that point. So really interesting times as to what's going on now. If you remember, we was looking at Hong Kong's data, and what we're seeing there in that region of the Earth is a slowly decline over the months of the microteslas. And you know, it's very difficult to put all these things into, you know, a picture where we could say, well, this is definitely happening, because, you know, different things are taking place in different parts of our world. So something under that mantle, you know, where the magneto is generating these poles, you know, there is different parts of that. And, you know, this is what we're trying to understand, how it all comes together to make, you know, up the magnetosphere in turn, and then the magnetic poles, how it all works. This is, you know, the only way we can find out that is by collecting more data, getting a bit of a better understanding as to what's going on. But, you know, at the moment, it seems it's a lot like the weather. You know, in different regions of the Earth, we have different climates, different seasonal weathers, and it seems like the very same thing is taking place underneath the crust of our Earth. You know, we have different regions with different activity, and at some times they behave a little bit more exotic than at other places. So, you know, it's well worth following us with regards to the data that we're collecting, because we're getting there slowly, we're getting an understanding, but more importantly, we've got, you know, pins on the most active regions of our planet right now with the magnetometers, and, you know, we can make a lot of progress in learning what's going on, and eventually, you know, we're going to put this all together and work it out, especially when we start putting, you know, the muon detectors, you know, detecting particles of muons in these different regions of the Earth as well. We get a better understanding not of just what's going on under our crust, but what's going on out of our atmosphere with regards to the magnetosphere. And as we're talking about that, let's go and have a look at the data that we collected over the last month with regards to the magnetic field, or the magnetosphere strength. So it's the latest magnetosphere data with regards to the actual magnetosphere strength. Now, I just want to mention I've mentioned it a few times. Don't get confused with the numbers down the side of the chart. It's just a reference point. We only have a total of 58 microteslas field strength on our planet protecting us. And, you know, as you've seen, at some regions of the Earth like Hong Kong, you know, that has dropped over 10% in 6 months. So, you know, if we see on our chart with the reference at the side, it dropped to say 195, all this we'd have to do is to deduct the 4 microteslas off of the total 58, and we would get an idea as to how much the field strength in total is declining. I'll just go over the last few months. It's actually quieting down. It's a lot like what we're seeing with the TriMag data, that calming down. Not so much of any sporadic movements like what we were seeing, say, like here on the 17th of the 8th, 2019. But in general, it is still at its same field strength since we started collecting data on the actual field strength. Now, we're not seeing the same data from other locations in the world where we've got our magnetometers. And, you know, again, it's like the weather. Underneath the crust, we've got different weather activity, if you want to look at it like that, with magnetic swirling molten iron, which is what they believe generates the magneto in our Earth, which in turn generates the dipoles and the magnetosphere. But, you know, we've also got weather on the surface that we experience. You know, we're all aware of what's happening with that and how much the effects of the magnetic poles and the grand solar minimum is affecting our jet streams, and then in turn affecting the weather on our planet. But we also have another layer of weather. It's like, you know, I was talking about in the Bible, you know, the affirmatives being separated. Again, we've got another weather outside our atmosphere, which is related to the magnetosphere. And these are the 3 things that we are concentrating on at our observatory right now. So, on the topic of muons, over the last month we've had 522 muons per hour on average per square metre. So, you know, slightly above the last time we've done a reading on the muons. Now, I'm looking forward to getting these muon detectors out into Brazil and South Central Australia to work out how much is coming in Australia, where there's a large intensity of magnetism, hopefully protecting more than over in the Brazil region, which is situated, as you probably know, in a region of our Earth called the South Atlantic Anomaly, and that's because it's the lowest intensity. I'm really curious to see how many muons we get per hour per square metre in both these regions, and in the coming month we should have, by the end of this month, we should have them already in their positions, along with 2 more magnetometers for those regions as well. So I'm looking forward to that, guys. Right, yeah, on the topic of something more important, guys, over here in the UK, you probably know that we're extending our rail network, and we've got this project going on now, which has just been given the green light to invest £104 billion in a high-speed rail. Yeah, and the reason why I'm mentioning it is because of just what people will, or what governments will invest in, as opposed to what I believe should be invested in. Now, obviously, if we look over in Europe, you've got the Large Hadron Collider, and that costs billions. We've also got, in various places of our world, a lot of money in the tune of millions, may even be close to trillions, being invested in fusion energy. But I just want to say, where is the investment in the study of the Earth's magnetic field reversing? You can invest billions on all these other things, and they won't really affect many people's lives, okay? They might commute from A to B a lot faster on a high-speed rail, and it's going to cost £104 billion. Where's the money being spent on what is really taking place with regards to this rare anomaly that is taking place on our Earth, the magnetic reversal? Why is there not billions of pounds being invested in this? And, you know, if it is, why we aren't aware of it? I just don't see where the common sense is. Do you guys? We are in a time where the Earth is being punished by cosmic particles coming through the upper atmosphere, and at the same time there is no investment in that field of research, or at least what we know of. Now, if you can afford to spend £100 billion on a rail, then why can't you afford to spend a few of those billions on some proper research into the magnetic pole reversal? This is a rare event. I would rather see that £104 million billion, and I think you guys would, being invested into this topic, wouldn't you? And I'd love for that organisation that got that funding to be making it public so that everyone could see what was going on in a similar manner to what's going on with CERN right now. And I know there's speculation as to what they release and, a lot of the experiments, whether they are, made public or not. It's another argument, but the point is, where is the money being diverted into this field at the moment? Because this field, right, is important to us all. Our jet streams have been altered through the fact of more cosmic radiation, creating seeding platforms, and as a result of that, it has changed the climate on our planet. It's not CO2 like everybody else is talking about with that religion, and that's all it is, a religion. If you haven't got the inclination to go out there and buy your own CO2 meter, or find someone with one of those CO2 meters and find out what the actual associated risks are with an increase of CO2, and you're just solely believing what everybody else is saying, then you are tied into this religion. It's clear. You've got to get out there and do it. And that's what I believe in. That's why I say, we are at this observatory proactive. We are actually building the equipment, getting the equipment out in the field and all over the world. We've used YouTube as a vehicle to encourage people to get involved with this and take these magnetometers on board and put them in their houses and collect the data and send it to us and get that data back to us so that we can process it and have a look at what's going on and inform the public. But where's the funding for what is really important in our world? We're seeing agricultural land go offline as a result of changing seasons. It's catching out the professionals. These farmers are the professionals of what they do. They know how to grow, when to put the seeds in, when to get the crops out. It's even catching the professionals out, guys, with what's taking place. And we are at some point going to, be affected even more so than what we are with regards to what's taking place. We're on the edge right now of the cliff, and it's not going to take much to push us over. And when we do go over, you've got only your insurance policy, hopefully, which is your bug out kit and some food preparations that you've put up to look after yourselves. Because when it happens, and it can create so many different scenarios, grid down, economic collapse, or social unrest and disorder on a grand scale that world governments can't cope with. When it happens, and it's not a case of if it's going to, it is going to happen at some point in our future. I've put a timeline down of about 3 to 7 years when the poles go into a reversal. And if we are in, at that point, an active solar cycle, which it doesn't look like we would be, but I'm just saying that there's lots of different scenarios. But if it was, and our magnetosphere is weakened, and we get a moderate solar flare, it's going to knock the grid out, I guarantee you. All your electrical goods and things aren't going to work. And this isn't just, dreaming about this. This has happened. It was called the Carrington event. And we didn't have much technology back then when it happened. We had that X-class flare. I think it was, off the top of my head, was it an X10 or X20? It doesn't matter. When we had that, the only technology we had was telegraphs. Today, we are totally reliant and dependent on technology. Lots and lots of microprocessors, all vulnerable to strikes by cosmic particles. And if that does happen, we could see the grid go down, and it is sayonara from there on. Anyway, guys, hopefully you've enjoyed today. We've got through a lot of stuff. We're waiting on a couple of things now just to finish off those muon detectors. The magnetometers are all sitting here ready to go out. I'm going to be busy this week Doing a few changes on the website because we've got Arizona coming online now with another magnetometer, and I'm going to get that ready for all the data to be collected and stored on there. But more importantly, guys, it's funding. We need funding. You can see how much we're doing now at the MagStar Observatory. We just need a little bit of a push from a few of you guys, and I just want to say thank you to all those that do support us already. It's only a small amount. Go on to Patreon. We've got less than 200 people supporting us on Patreon, and you know, occasionally we have someone chip in a few bucks on PayPal. Just if you can, guys, you know, help us out here, and in turn you get something back out of it. You know, I say this all the time, there's a lot worse things you can do than support an observatory that is covering one of the most significant events of our time, and in turn, you know, relaying that information back to everybody. You know, we don't charge everybody for the information, we give it freely, but you know, it's like everything else. If there's no funds coming in, then it shuts us down completely over here. So, you know, I'll just say, guys, the link's there. We need your help. Okay, I'll say nothing other than have an amazing day. I'll be back tomorrow, and guys, as always, bye for now.